All right, we're going to be talking more about circuits today. Remember last time we were talking about a series circuit, and so here's our battery pack. We got a wire connected to a light bulb. We got another wire connected to a light bulb and back. This is series because there is one path, right? Electricity has to flow out of our battery pack through the first wire, through the second wire, through the third wire. There's two light bulbs, but it has to go through both of them, right? Okay. And if you can imagine, or actually we won't imagine because we'll do it, what do you think is going to happen if I take away this wire? What's going to happen to my light bulbs? What do you think? Ah, they go out. And you're probably like, yeah, no, duh, they go out. Right? But let's think about why. Why do they go out? Well, what do we need for a circuit? We need a closed loop. And is our loop closed anymore? No, it's open now, right? Because I don't have one continuous path. It's been broken. And so when the path is broken, electrons don't flow. And without electrons flowing, we're not going to get light bulbs to light up, okay? All right, now we're going to take a look at a slightly different circuit. Here I've got my battery pack and I got a wire and then, ooh, what happens here? I got two wires. There's a split. And this first wire is going to go to a light bulb, okay? And then this second wire is going to go to a light bulb. And then over here, they're all gonna come back together. I don't know if I can show this to you. I'll try to zoom out a little bit more. Okay, so here we have a split. They go, each light bulb has its own connection to its own wire. Here they all come back together now. And so now I'm gonna finally close off my loop here and so there we go. I've got my two light bulbs light up. Again, we got a split. I got one wire going to this light bulb on the right. I have one wire going to this light bulb on the left. And then they both come back and go back to the battery. Now, what do you think is going to happen when I take away a wire like I did last time? Well, let's take a look. What if I take away this wire? Ooh, why does that one stay on? Well, this one still has a closed loop. Look, it's got a wire, boom. It still has a closed loop. This one goes out because its loop is closed, but the other one stays lit. Up, and if I plug it back in, they both get it. Similarly, I could undo this one, and now this one stays lit. Did you see how it got a little bit brighter there, right? Because it's got more current running through it. So again here, because we don't have one loop, we have two loops. If you disrupt one of the loops, the other one still stays intact and can still function without it. This type of circuit, in which we've got more than one path that the electricity can go through, this is called a parallel circuit. And that's what we're going to be dealing with today and this week. Okay, so now let's take a look at how we would draw the circuit diagram for that, okay? So, as always, we would start with our battery on the left, plus and minus. I don't know how many volts that was. Let's see, 3, I think these are all 3 volts, so we'll call it 9 volts, okay? And then, remember, we had 2 different branches. So the way that you draw this is kind of like this. So this would be our split here where the wire split into 2. And this is showing like the light bulb on the left and this is showing the light bulb on the right. So we would make 2 light bulbs here. And we put in whatever their resistance is. I don't know off the top of my head. We'll call it 1 ohm for each. Okay. And so then here is them coming back together right here and then going back to the battery. So that's how we draw a parallel circuit. Instead of just one square, we have kind of like a second arm. And you can imagine if there was a third light bulb, then we would draw it in right there, right? But we don't have a third light bulb. But if we did, that's how we would do it. And so that's how you draw those circuits. So when you see that diagram, that's what it means, is that here there's a branch and wires go to kind of to 2 different places, and here's where they merge back together to return back to the battery. So let's take a look at some of the general things you'll need to know about parallel circuits, some of the math you might be expected to do, so that you are good to go with this, okay? I'm gonna move my notes in here. All right, here we go. All right, so in a parallel circuit, there is at least one point where the circuit divides, and this creates more than one path for the current, unlike a series circuit, okay? And each one of these paths is called a branch. And since each branch has its own path to the battery, The voltage in each branch is equal to the battery's voltage, right? So this is gonna wear down a battery a whole lot faster. The current in each branch is calculated by dividing the voltage by that branch's resistance. And then to calculate the total resistance of the whole circuit, we're going to use this equation here. R1 times R2 divided by R1 plus R2. And one thing that's important to know is that the resistance of a parallel circuit is always smaller than its smallest resistor, okay? This is basically just explaining to you in words the math that we're going to be doing. If I were you, I would take a moment, pause the video, jot this down, and then when you're ready for an example, press play, and we will walk through an example together. All right, I'm assuming that you're ready to do an example. So here's one, okay? So here I've got an example of a parallel circuit. I've got a 12-volt battery, and I've got two different branches with two different light bulbs. One is a resistance of 2 ohms, and one is a resistance of 3 ohms. So if I'm looking for the voltage for in each branch, or the voltage that's going through each bulb, if I look back to my notes, that is just going to be equal to the battery's voltage, okay? So what's my battery's voltage? 12. Okay, I'm gonna just move this ever so slightly so we can see it. There we go. And so my answer here for the voltage would be 12. Each bulb is getting 12 volts. Now, what about the current in each branch? If I go back and I look at my notes, it says the current in each branch is calculated by dividing the voltage by that branch's resistance. So for this branch, it's going to be the voltage 12 divided by 2, which is 6, right? Pretty easy. So it'd be 6 amps. And for this branch, it'd be 12 divided by 3, which would be 4 amps. Okay, so there's my math for that. Not too bad. Now the total current in the circuit. Well, if I've got 6 amps in this branch and 4 amps in that branch, 6 plus 4 is 10. I would have 10 amps total of current in this circuit. And now my total resistance, and that is this one right here. So I'm going to do R1 times R2 divided by R1 plus R2. So 2 times 3 divided by 2 plus 3, okay? So 2 times 3 is 6 divided by 2 plus 3, which is 5. You got to do your order of operations. Do your 2 times 3 and your 2 plus 3 first, and then do your division second. So first you got to get your 6 on top and your 5 on bottom, and then 6 divided by 5 is 1.2, okay? Another way that you can do this is you can use Ohm's law. Remember that resistance, if we rearrange our triangle, is equal to voltage divided by current, okay? And so if I have the voltage, which is 12 from my battery, and I know that my current here is 10, I could do 12 divided by 10 to give me 1.2 ohms, okay? So that works both ways. And so that's the math that I could do for a parallel circuit. This is how you draw a parallel circuit. And the rest of your assignment this week are to do some parallel practice problems. Hopefully this was helpful to you. If not, please come to one of our Zooms to get your questions answered.